Good morning everyone. We'll continue with the chapter metals and non-metals. We did the physical properties last time and this time we are going to start with the chemical properties. Right? Chemical properties means how they react with the other substances, like reaction of metals with oxygen or with water, with acids, etc. Right? So first of all, we'll start with the reaction of metals with air. When we talk about air, we are talking about oxygen. Right? So some of the metals, they are very reactive, like sodium and potassium. They are so reactive that they react with the air or the oxygen present in the air, with the oxygen, moisture, carbon dioxide, that so much of heat is created that they explode also. Right? They react so vigorously with the air. That is why they are kept in kerosene oil. Sodium, potassium and even lithium. Lithium is also highly reactive. So these metals, they are kept under kerosene so that the supply of oxygen, the oil will cut off the supply of oxygen. So the metal will not come in contact with air. Right? So that is why they are dipped in kerosene oil all the time. So these metals like sodium, when it reacts with oxygen, it forms sodium oxide. Potassium will form potassium oxide. Metals, whenever they react with oxygen, they form metal oxides. Right? So, and then like aluminium, when it will react with oxygen, it will form aluminium oxide. Now, most of the oxides which are formed, they are basic in nature. Then you can take other examples also, like magnesium. You have learnt about it in first chapter also, that when magnesium is burnt in the presence of air. Now these two metals, sodium and potassium, they can react with oxygen at room temperature only, without any, we don't have to burn them. But other metals like magnesium, etc., we have to burn them in the presence of oxygen and then it forms magnesium oxide. Right? Now iron does not burn when we heat it, but in the presence of oxygen, right, it forms a layer of oxide over it. Iron, if kept in open for some time, it reacts with oxygen and the moisture present in the air and forms a layer of Fe3O4, that is rust over it. Right? Now copper will not burn like this in presence of air. Right? Then there are metals like silver and gold. They do not show any reaction with oxygen. Now this aluminium oxide, it will be formed, aluminium plus oxygen will form aluminium oxide. Most of these oxides, they are basic in nature. Right? We can even test them with the help of pH paper. You have learnt about this before also, that basic oxides are formed, right, whenever any metal plus oxygen will react. It will form oxide which will be basic in nature. But some of these oxides, they show both the behaviors, acidic behavior also and basic behavior also. So such oxides which show both the behaviors, that is acidic also and basic also, they are known as amphoteric oxides. One thing more I'll tell you here, these oxides, whenever some of these oxides, not all, some of these oxides, they are insoluble in water, but some are soluble in water. The ones which are soluble in water, they will form the alkalis. You've learned this in second chapter also. So like sodium oxide, potassium oxide, when they will try to dissolve them in water, whenever they react with water, they form alkalis. Right, and these amphoteric oxides, you can take the example like Al2O3, aluminium oxide. It can react with the acid also and with the base also. So when it reacts with acid, it will form aluminium chloride plus water. When it reacts with sodium hydroxide, it will form sodium aluminate plus water. That is, it shows acidic behavior also and the basic behavior also. Same way zinc. Zinc oxide, it will react with hydrochloric acid to form zinc chloride plus water, and with the base it will form sodium zincate plus water. So these are the examples. Aluminium oxide and zinc oxide, they are the examples of amphoteric oxides which show both the behaviors, acidic oxide also and basic oxide also. Then next comes reaction of metals with water. So here, whenever any metal reacts with water, it forms a metal hydroxide. Right, first it forms metal oxide, and then again that metal oxides, when it comes in contact with water, it will form metal hydroxide plus hydrogen gas is given out. But when metal reacts with steam, not with water, but steam, that is the gaseous form, it will form metal oxide, not metal hydroxide. This is very important for you to remember, that metal plus water, it forms metal hydroxide, but metal plus steam forms metal oxide. Now, the first one, if you take potassium. Potassium, when it comes in contact with water, now again the sodium and potassium, because they are highly reactive metals, when they come in contact with water, they will produce lots of heat because hydrogen gas is given out. And this hydrogen gas, because so much of heat is created that it will explode. Same way here with sodium also. Here also, when sodium comes in contact with water, so much of heat is given out that the hydrogen form will react with the heat. When it comes in contact with that heat, it will explode. Sodium and potassium both are highly reactive metals. So before I proceed further, I would like you to see this series. This is known as metal reactivity series. Now this metal reactivity series, what it is? It is the arrangement of metals in a vertical position, right? From the most reactive metal to the least reactive metal. This potassium, this is the most reactive metal, and gold, it is the least reactive metal. So you have to learn this series. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead. Then comes hydrogen. Now why is hydrogen placed in the metal reactivity series? This is a non-metal. But we all know that hydrogen, it always gives away the electron. Right? So it has a positive ion here. Like all other metals also have a positive ion here. They are electropositive in nature. Same way, hydrogen also gives away one hydrogen electron. So that is why hydrogen has been placed here. Then comes copper, mercury, silver and gold. So you can learn it by learning this name, that is Professor S.C. Mezitel. Professor. P stands for potassium. Then S stands for sodium. C for calcium. M magnesium. A aluminium. Z zinc. I iron. Then T tin. L lead. So if you remember this name, Professor S.C. Mezitel, you can easily learn this reactivity series. And below hydrogen are copper, mercury, silver and gold. So learn this reactivity series, then you will be able to learn this also, how the reaction takes place. Like sodium and potassium, which are the most reactive metals, they react with water even at room temperature. They react with the moisture also which is present in the air and they can explode. That is why, as I told you, they are kept in the kerosene oil. Then all the metals do not show the same reactivity with water. Some react with hot water, some may react with cold water and some react with steam. Like calcium. Calcium always reacts with cold water to give a hydroxide, metal hydroxide, that is calcium hydroxide plus hydrogen. But here the heat produced is not that vigorous or not that much in quantity that hydrogen may cause an explosion. Here what happens, after the reaction, calcium, it floats on water. Why? Because these hydrogen bubbles, they come on the surface. You know, the bubbles will come, the gas will come on the surface, right? And that will stick on the surface. Same way, magnesium, it reacts with hot water, it cannot react with cold water. So magnesium, when it reacts with hot water, it will form magnesium hydroxide plus hydrogen. This magnesium hydroxide also starts floating on water, right? Now why? Because here also the hydrogen gas which is produced, the hydrogen bubbles will come on the surface and stick on the surface. Now some other metals, like after calcium, magnesium comes aluminium, zinc, iron. These, they do not react with hot water or cold water. They will react only with the steam. This magnesium, it can react with hot water also, and this magnesium, it can react with steam also. Whenever we write steam, like we are writing Mg plus H2O, this shows it is reacting with water. But if we write G here in the bracket, that shows it is the gaseous form. So whenever we are showing reaction with steam, we should write G in the bracket after writing H2O. So Mg plus H2O, it will form magnesium oxide. As I told you, metal plus steam will always form metal oxide. Here with hot water, it forms magnesium hydroxide, but with steam, it will form magnesium oxide plus H2. Same way, aluminium, it will form aluminium oxide plus H2. Zinc plus steam will produce zinc oxide plus H2. Iron plus steam, it will show Fe3O4 plus H2. Right? A question can be asked in exam also. What happens when steam is passed over red hot iron? Then you have to show this reaction, that iron oxide will be formed, not the hydroxide. Then metals like this lead, copper, silver, gold, they do not react with water. Neither with cold water nor with hot water, they will not show any reaction. Right? Then this thing we can also, that hydrogen is produced. This thing we can show with the help of an experiment also. Let's take that experiment. If we take a boiling tube, right? boiling tube. And place some glass wool here. And we put some metal here, any metal here. So this is glass wool, moist glass wool you can say. That is mixed with water. And this can be any metal. It can be aluminium, it can be zinc, it can be iron, right? We put a stand here and we try to fix this, right? We will fix this boiling tube here, and from here we pass a delivery tube into the trough of water. Then here we place an inverted gas jar and the delivery tube passing in this, right? So here we have water. Now what will happen when we heat this glass wool and we heat this metal also? What will happen? The moisture which is present here, the glass wool will not have any effect of heat, but the moisture which is present, that will start passing. That is, steam will be produced. That will pass over this metal which is being heated here. When it comes in contact with this, the steam will come in contact with the metal, hydrogen gas will be produced. That gas will pass through this delivery tube and get collected here in the gas jar. When this gas jar is filled with the gas, we again remove this and bring a burning candle near the mouth of the gas jar. What will happen? Yes, the candle will burn with a pop sound, which is the characteristic of hydrogen gas. Right? So this way we can prove that hydrogen gas is released whenever any metal it comes in contact with water. The next one is, the third one is reaction of metals with dilute acids. We have already learned in the chapter of acid, bases and salts that whenever any metal it reacts with acids, what is produced? Yes, it is salt plus hydrogen gas. Right? Like if we take the example, we take from here only, we start with Na plus HCl. We take dilute hydrochloric acid, it will produce NaCl plus H2. You can balance the reactions. Right? Same way, we take any other example like K. We take another acid, H2SO4. It will give out K2SO4 plus H2. Or we take Mg plus HCl. It will produce MgCl2 plus H2. Zinc, if we take zinc plus H2SO4 or HCl, we can take any acid. It will form ZnSO4 plus H2. Right? So, always hydrogen gas is given out plus a salt is formed. But, if we talk about nitric acid, HNO3. Now this HNO3 does not liberate hydrogen gas when it reacts with any metal. This is a very important question also. Why hydrogen gas is not given out when any metal reacts with nitric acid? The reason behind this is, this HNO3, it is a very strong oxidizing agent. Right? Strong oxidizing agent. Now, because it is a strong oxidizing agent, what will happen? The hydrogen gas released will immediately turn into water. Because it is an oxidizing agent, it will oxidize hydrogen and form water. Oxidizing agent means it will add its oxygen. So what will happen? It will immediately form water. Right? So that is why hydrogen gas will not be liberated out, and itself it will get reduced to any of its nitrogen oxide, either to NO2 or NO or N2O. Right? So this is a very important question also. Why metals do not show reaction with HNO3, or why they do not liberate hydrogen gas? Why? Because HNO3 is a very strong oxidizing agent. It will immediately convert hydrogen into water, and itself it will get reduced to any of the nitrogen oxide, that is NO2, NO or N2O. But there are two exceptional cases also. Now, what are these exceptional cases? That is magnesium and manganese. This magnesium and manganese, they react with very dilute HNO3. Now, because it is very dilute, it will become a weak oxidizing agent and will not be able to convert hydrogen into water. So with magnesium, it will form magnesium nitrate plus hydrogen gas will be given out. Same way with manganese also, it will form manganese nitrate plus hydrogen gas. Right? So these are the two exception cases. These you have to learn also. Next is reaction of metals with other salts. Now, how it reacts with other salts? Other salts you have read also before, like in first chapter you read about the displacement reactions. Right? Now, for this it is very important to learn this metal reactivity series. You know that only the metals which are more reactive can displace the less reactive metals. So you can come to know from this series which metals are more reactive than the other metal. Like if we take the example of iron nails. Iron nails, when they are dipped in copper sulfate solution. So what happens? Now this iron, it is more reactive than copper. So what will happen? It will displace this copper and take its place. In place of copper sulfate, now it becomes iron sulfate plus copper is displaced. Or we take the other example like Zn also, zinc also we can take. Now zinc plus copper sulfate, if we place zinc metal in copper sulfate solution, again it will be able to displace this copper and Zn sulfate, that is zinc sulfate plus copper will be formed. Right? But same way with lead also we can take. Lead plus copper sulfate. This will also form lead sulfate plus copper. But if we just reverse this, in place of putting iron in copper sulfate solution, we put copper in iron sulfate solution. What will happen? No reaction will take place because copper is less reactive than iron. So these type of reactions sometimes come in exams also to complete the reactions. You should know the metal reactivity series so that you can make out whether it will be able to displace the reaction, displace the other metal or not. Right? So if you know the reactivity series, you can very easily write these reactions also. So what happens? Always the more reactive metal is able to displace the less reactive metal. So these are the main properties, the chemical properties of metals, right? One more thing, that is, I want to tell you about Aqua Regia. Now what is this Aqua Regia? Aqua Regia is a solution of HNO3 and HCl. But it is not present in any ratio. It is always present in the ratio 1:3. That is 1 part of HNO3 and 3 parts of HCl. This is a very strong solution. It can even dissolve gold, silver and platinum in it. Right? That this is how the jewelers, you take your ornaments for washing or anything, for cleaning them. What they do is they dip it in Aqua Regia. You don't even come to know, in front of you also they will clean it. They will just give you, when they will dip it in this solution, what will happen? Some part of gold, it will dissolve and go in that solution. And they will take out your jewelry in front of you only, that they have. See how nicely they have cleaned it and made it shiny. Right? So what will happen? Some of the gold has already gone in that solution. They will collect it afterwards from there. So never give your jewelry for cleaning to the jewelers. This is how they remove some of the gold from it. So Aqua Regia, it is a solution of 1 part of HNO3 plus 3 parts of HCl. Right? So now next rest of the chapter we'll take up in the next video. Till then, keep studying and keep safe. Thank you.